So now I'll go through examples for counter up, counter down, and up and down counter. So let's see an example of using a counter up in PLC programming. For example, let's say we have a sensor on a conveyor to count 24 cans that go into a case. And while the counter is counting, there's a yellow light that turns on indicating that the case is not full yet. Once the counter reaches 24 cans, then there is a green light indicates that the case is full and it's ready to go to the next step. We need to have a reset push button that can reset the counter to fill in another case. So in the PLC program, we have a sensor as an input. Note here we're using an XIC instruction and having the counter as an output for that specific rung. We need to give the name to the counter and specify the preset as 24. After using the counter, we need to associate the yellow light to the counter while it's counting. So the bit that we use here is counter up bit. Remember that we need to use this name of the counter and select the counter up bit. Now in the second rung, the yellow light will turn on as long as the counter is counting and not finished yet. Then to program the green light, we need to show that when the counter is done counting, when the case has 24 cans, then the green light turns on. So we need this time we used the done bit of the counter and associated that with the green light. And I'm using an XIC instruction. Remember that an XIC is activated when the memory location is 1. So the bit, the counter up bit, is activated when the counter is counting, and then the done bit will only be activated when the counter is finished counting. And in order to reset the counter, we are going to use a reset instruction, and remember that we need to use the same name of the counter. So we add a push button XIC instruction and have the reset instruction as an output to that specific rung. The second example is using counter down. For a counter down, each time the counter sees a false to true rung transition, its accumulated value is decremented by 1. Since the accumulated value is decremented each time the input logic changes from false to true, the accumulated value must be starting point of the count. For example, when counting a batch of 100 parts, each time the part is made, the remaining total is displayed on an operator interface so that the operator can see how many parts are needed to be manufactured. So every part that is being manufactured, the remaining total is displayed. For the counter, accumulated value will be programmed with a value of 100, the total number of parts, whereas the preset value will be 0. In this case, the accumulated value will be set to 100 and the preset value will be 0. So each time a part is completed and passed through the sensor, the accumulated value will be decremented by 1. When all 100 parts have been made, the accumulated value and the preset value will be 0. The done bit in the counter done is activated at that point when the accumulated is equal or greater than the preset value. The value that we need to send to the monitor is the counter accumulated value because we want to see how many parts are left. We name it as the counter name .acc, which is the accumulated value. And I'm going to use a move instruction to move it to the monitor. The last example is combining up and down counter. So let's take an example where we need to keep track of the net numbers of parts on a conveyor. The number of parts going on the conveyor is counted by a proximity sensor, and the number of parts leaving the conveyor is counted by another proximity sensor. If we want to keep track of the same entity, we use the same address, the same memory location for both counter up and counter down. So we use a separate count up instruction and a separate count down instruction with the same address, with the same memory address. Sensor 1 will increment the counter up and sensor 2 will increment the counter down. Since both counters share the same address, the accumulator value will be shared between the two counter instructions. And because the accumulator is shared, it will reflect any count seen by either count up or count down instruction. And we're doing the same thing. We are going to use a move instruction to move the accumulator value to the monitor to show how many parts are left.